Hello, this is Jan from Repair. Today we will go through a Dell Inspiron 10th generation i7 repair that came to our lab literally drowned in the water. Let's see how we deal with this and you will understand. This is the board on the desk. We will now plug the Type-C charger in order to check for consumption. And we have 20.4 volts and 0.01 amps. By pressing the power button, nothing is different. There is nothing warm, it is only a flat 12 volts and 10 milliamps consumption. We must make an optical inspection now to check if we have something weird on the board as it was suffered water damage. On the upper side, I have already noticed that there is some corrosion on a capacitor. Let's see where, and here it is. If we turn the board upside down to check the bottom side, we will face a charging IC water corrosion. The area around it is not in a good shape too. There is much corrosion in all the components that are part of the charging IC. Let's add flux and use our hot air to clean. After that, we will measure the values of the resistors around. As we reflow, the reflow is happening and we go through and move the IC and the components around it to refresh the solder. We are trying to go easy on the reflow with low air and a lot of flux. Flux is helping to remove oxidation from metals, from the solder, and that is making our job easier, our life easier for removing the corrosion from the solder pads. Let's clean with isopropylic and check again if we have any differences. The area looks good. And now we must measure the values of the components around. We will start with this 2.2 ohm resistor, which is not. It's something much bigger. It is almost open. Let's go and check if this 2 ohm resistor is good, and it is. Let's check this resistor here, which is not a 2 ohms resistor anymore. Its value is some kilo ohms and it should be 2 ohms. The result is that we must change the two resistors, the small one with the 2.2 ohms and the big one with the 2 ohms. Let's check the schematics below. On pin 12 we have a 2.2 ohm resistor that is involving with the charging, and on pin 17 we have the 2 ohm resistor that is feeding the 12 volts on the charging IC. So let's go and change the resistors with new ones with the right value. The resistors are removed and the new ones are on the way. The 2.2 small resistor must be accurate in value as it is involved with the charging itself. The big one will be a 4.7 ohm and should be okay for feeding the IC with voltage. We will use our soldering iron, not hot air, to solder back the resistors. We will prefer to go to the bigger one. And as we will solder the bigger one, we will go to the smaller one, because smaller one need more detail. Flux is always a good thing to do. Let's clean around and check the values. The values are okay. We will go now and check for volt and amps consumption. Let's plug the charger again. And we have a good consumption and a power LED blinking. But as you saw, an IC exploded, with flames and smoke. Let's see which IC is that. This IC is an audio IC. We must remove it and check for any pads missing. The chip is off and let's see if we have a short there where it is burned. There is no short, so we're clear from source and we can proceed for the testing. We will put everything back on its chassis because Dell notebooks are complaining with no screen plugged. We will plug the charger and very low consumption. We must check further. As the only thing that we did different was that we have plugged the screen. We checked for the connector and here is what we saw. The backlight connector is destroyed too. We must change this connector due to corrosion and broken pins. The LCD cable is corroded. Not very much, it should work with some cleaning. The connector must be replaced. We are removing the connector with hot air and it is off. Let's check for pads missing. No pad is missing, we are okay. We will add solder, and with a wick we will clean the pads. Let's remove the connector port from the donor board. We will do it with caution for not deforming the connector. The port is off and is in a good shape. Let's install it on the board. We will align it on the board, and with flux and hot air we will solder the connector on the board. The process is slow on the air for not deforming the port. We will reinforce the ground pads with solder. And we are ready. Let's solder the pins now. We are done with this board. Let's plug again. Screen seems to have no backlight, but by pressing the caps lock on the keyboard we have a light. That means the notebook is on and display should be on, but there is no backlight. Let's go and see how we can fix this. After removing the screen, we have decided to disassemble and check for potential damage on the screen. It was very difficult to remove the cover. It is not the scope of this video. The findings were the following. The screen connector is damaged too, burned pins and pads. Let's see further. We'll remove the screen cable. The connector must be cleaned with isopropylic and tweezers. After the cleaning, we saw 4 pins were missing. The screen connector must be removed. We can clearly see that there is a lot of work to do in order to repair in a way the connector to fully test the notebook. Let's clean, scrub and solder whatever we must do in order to do the job properly. We will clean what we can from the connector. We will solder back the connector and try to restore the pins. We must be extra cautious because the flex of the scalar board is just below. We align the damaged connector and we're trying to solder it back the right way and align the pins with the pads in order to check the missing pins and try to restore them. The first thing is to anchor the connector with a big ground pads with a lot of solder to be stable, and then get to work with the pins. Let's scrub the plastic with a polisher for the pins to appear, so that we have a chance to solder the missing pins on the pads. Now that some pins are showing behind the plastic, we can try to flex and solder and tin them in order to try and wire a cable from this copper that is showing on the plastic to the pads. As you can see, all the 4 pads are missing are from the backlight. It's the same pin, so it is easier for us to wire. The job is done. We have soldered the pins on the pads. Let's check the notebook for any sign of life. We will put everything back and test. The screen has a backlight now, and everything now can be tested. The notebook is fully on for the testing. As you can see, there is a mess from water inside the screen. We have done it, the problems are no more.
That was the repair, as you saw. It was a difficult one. What we did with the screen, it was to repair the connector to check if we have display or not, to ensure that the computer is okay, to check for the price for our customers. If you liked this video, consider like, subscribe and share. Thank you for watching. See you in another repair. Bye.